EXO guys were in the meeting yesterday and mentioned that last week you guys tested and did the 100 gig and it worked well. I was wondering if you could comment on that, comment on when you think that'll be readily available, as well as the 400 gig pick that you were just talking about.
Yes.
You know, I mean, crystal ball. I'm not going to pin you to anything right now, but.
Yeah. So, but the demo that was done was a pre-standards implementation of 100 gig Ethernet. So it was driven from a test set delivered by Ixia. In terms of actual 100 gigabit Ethernet becoming available, really IEEE needs to finalize their standards definition. I think they're probably about a year and a half away from formal final ratification of that. However, the whole supply chain in the industry is getting ready for it. So you've got the test set manufacturers that are starting to come out with beta versions of analyzers and so on. You've got the components industry that's going to have to deliver the short reach interfaces that connect the routers to the transport and so on. They're starting to come out with some pre-standards versions of those optical components. It's going to be either 10 by 10 gig parallel lanes or 4 by 25 gig parallel lanes. You're starting to see some data availability of those components. What we did in Infinera was demonstrate now on the WAN side, the ability to transport that 100 gigabit protocol across long haul networks. Right now we're doing it 10 waves over 10 gigs using our 100 gig picks. But that's part of the the point of being able to abstract the service from the underlying capacity, and we introduce 400 gig picks or terabit picks. Well, you don't need to couple the service to the bandwidth. You just want the bandwidth to carry the services. In terms of the 400 gig picks, those are going to be available next year, where we're going to start designing those into our next gen system. We haven't made any formal announcements around our next gen system, so a year or so after that.
You mentioned physics and an upper limit. Can you talk a little bit about that? Because if we're at 10 gig now, 100 gigs being demonstrated, and you say that terabit is pretty much physics limit, that doesn't give us very much headroom here, does it?
No, not really. So Magic State is already today so each time you increase the bit rate on the optical fiber at which you're transmitting, there's a lot of the impairments like PMD and chromatic dispersion that scale exponentially to the square of that. So that means that if you keep the same transmission technology, you're going to go, if you quadruple the bit rate, you're going to go 1/16 as far. And so already today, just to get 40 gigabit transmission working along reasonable distances, and being able to overcome some of these optical impairments and get out to reasonable reaches, most people doing that are doing very advanced modulation schemes, where instead of just turning light bits on and off, they're modulating 2 or 4 phases of light, in some cases modulating 2 polarizations of light. And what's happening with that is you are able to get more or less 10 gig equivalent reach at 40 gigabits, but you're using 4, even 5 times the number of optical components, because you're having to do really sophisticated modulation schemes. So already there, we're starting to see part of the scaling equation breaking down, because you're moving to 4 times the bit rate, using 4 times the components, and therefore at 4 to 5 times the cost. So you're not getting any reduction in the cost per bit as you're moving to 40 gigs. So really the only viable reasons people are moving to 40 gig is to get some IP traffic efficiencies, or to maximize the amount of capacity they can pump into their fiber. 100 gigabit, the technological path to get there is fairly clear. It's going to be using some of these very advanced modulation schemes, just at about twice the bit rate of what they're being used at today. You could probably scale to 200 gigs per wavelength, but after that, the component complexity, to do anything beyond that is going to start exploding so enormously it's never going to be cost effective. And the other thing as well is that when you use 4 or 5 times the number of components on a line card to scale to 4 times the bit rate, you're not saving anything in terms of space, fiber coupling, or power. So therefore, all of those very important OpEx aspects of your scaling equation aren't getting fixed at all. So photonic integration, for example, helps that, because now you can afford to use 4 times or 5 times the components, because you're packing them all into one chip. You're not having to build a of a whole bunch of discrete devices. But other aspects of fiber scaling which really haven't been explored much yet is today all networks really use only about 1/5 to 1/8 of the total fiber capacity. So there's huge parts of the optical fiber spectrum that never get used at all. Opening those up is going to be a very important way to scale total fiber capacity. And again, you want to be able to do that cost effectively, which means being able to open up more capacity with as much density on the equipment that does that as possible. So those are going to just, I think, over the next couple of years, are going to be things we're going to start seeing. It's not just going to be a discussion of how many bits per wavelength you pack, what's the fastest speed per wavelength you can do, but it's also the density at which you get that, and it's also going to be about the total number of wavelengths you're going to be able to.
So you see the S and the L band being used, not just the C band, basically?
Yeah, that's right. And even going into the 13, 10 nanometer region and so on as well. Yeah, absolutely.
All right, so I have another question. So how does that translate into prices from carriers for services? Better? I mean, if we start seeing, not just your technology, but we start seeing we start seeing newer chipsets, more use of wavelengths, although that's going to cost more for CapEx, is it truly going to drop down the cost on carrier services?
So, typically, carrier service costs have somewhat followed, or maybe the relationship is the other way around, but have followed the price for the equipment. I think one of the areas where the industry is a little bit stuck right now is a 40 gig transponder costs about 5 times a 10 gig transponder. So it's really hard to sell that 40 gig service with a cheaper cost per bit than the 10 gig service. In fact, 10 gig services today is still much cheaper to deploy, and the cost curve on that is still continuing to decline. So I think what's going to need to change, and certainly Infinera's view is that photonic integration is really the only viable technology that's going to enable that, is that you need to get more capacity at a lower cost per bit, and you do that by reducing the number of components, packing more inside a single chip or device. Okay, well, thank you very much.